Welcome to Brain Vision.
So for this problem, the angular acceleration of the pulley will be directly proportional to the radius. So we can write for pulley B, alpha 1 is the acceleration of pulley A. So for pulley B, alpha 2 will be equals to R1 by R2 multiplied by alpha 1. And for pulley C, we can write alpha 3 equals to R1 by R2 multiplied by alpha 2. So from here alpha 3 will be equals to alpha 1 multiplied by R1 by R2 whole square. Okay, so from the definition of angular velocity, we know that omega equals to omega naught plus alpha multiplied by t, where alpha is angular acceleration and omega naught is initial speed. Okay, as initial speed is 0, so from here angular speed of omega c for the pulley C is equals to 0 plus alpha 1 multiplied by R1 by R2 whole square multiplied by t. So from here angular speed of pulley C comes out to be alpha 1 R1 by R2 whole square multiplied by t, which can be rearranged in the form as omega C equals to R1 by R2 whole square alpha 1 multiplied by t, alpha 1 multiplied by t. So this is the answer for the first part, in which we have to determine the angular speed of the pulley C. So moving to the next part B, in which we have to determine the acceleration of point P. So now we can find the magnitude of acceleration for a point by adding tangential acceleration and radial acceleration. So first of all, the tangential acceleration of the point is given by at equals to dv by dt equals to r d omega by dt. Okay, so from here we can write that r2 alpha 2 will be equals to alpha 1 r1 square divided by r2. Okay, and radial acceleration will be equals to ar equals to v square by r or r omega square. So by putting values, ar will be equals to r2 and omega is r1 by r2 whole square alpha 1 multiplied by t. Okay, so net acceleration a will be equals to a r square plus a t square under. So by putting values in this equation, acceleration a will be equals to r2 r1 by r2 whole square alpha 1 t whole square plus alpha t, which is equals to alpha 1 r1 square divided by r2 square whole square. Okay, and under root. So after solving this equation, the acceleration of the particle P comes out to be r1 by r2 r1 square by r2 alpha 1 under root 1 plus r1 by r2 power 4 alpha 1 square t power 4. So this is the answer for the second part, in which we have to determine the acceleration